Let's take a look at how to draw the dot and cross diagram for fluorine molecule. So for fluorine, right, I will start with the electronic structure of the atom itself. So you all know for fluorine, okay, so I'm trying to draw your fluorine gas, which has a chemical formula of F2. Alright, chemical formula of F2 because it exists as a diatomic molecule. So let's take a look at your one fluorine atom first. Okay, so for each fluorine atom, if you go to a periodic table, you'll find that it has 9 protons. Okay, so it will have electronic structure of 2 7. So I'll just draw the atom first. In the first column, electronic structure of the atom. So 2 electron shell with 1 2 1 2 3 4 5 6 and 7. So this is how your fluorine atom should look like. Okay, so now how do you draw a dot and cross diagram for your fluorine gas and F2? So since you know that it will contain 2 fluorine atoms, right? If you don't know how they actually share the electron to achieve the stable electronic configuration of a noble gas, what you can do is that you can draw another fluorine atom. Okay, so this time around I use dots. 1 2 3 4 5 6 7. Alright, so now to figure out how they share the electrons, right, all you need to do is to go and pair out the lone pair if any. So are you able to identify the lone pair? Okay, I think it should be straightforward. Okay, there's one electron here that's not paired, one electron here that's not paired. So all you need to do is just to pair them up. So these 2 electrons will be shared between the fluorine atom itself. Okay, so they'll form a single covalent bond. So let's take a look at how your fluorine molecule will look like. Okay, so I'll draw the fluorine molecule now. Take note when you're drawing, right, make sure that the size of each fluorine atom is more or less the same. Okay, so I'll draw in the dot and the cross. Okay, 1 2 3 4 5 6 over here. 1 electron that's shared between for each of the fluorine. Then I'll fill up the rest of the electrons. Okay, so this will be your fluorine dot and cross diagram for F2 fluorine. Now remember to write in the key. Alright, and last but not least, the structural formula, right, it will just be F arrow F. So it's just a single covalent bond. Alright, so this is how you draw your fluorine molecule. Now we move on to the second example. Okay, let's take a look at the second example then. Now that we're done with fluorine, right, let's take a look at oxygen. So how do you draw the dot and cross diagram for oxygen gas? Now for oxygen gas, right, in your worksheet, oxygen gas, chemical formula will be O2. Again, this is a diatomic molecule. So we start from your oxygen atom. Okay, so for oxygen atom, go to a periodic table. You should find that oxygen, it has proton number 8. Okay, proton number 8. So therefore, it should have 8 electrons. The electron structure will be 2 6. Okay, 2 6. So let's draw the electronic structure of your oxygen atom first. So 1 2 1 2 3 4 5 and 6. Okay, so this is an oxygen atom 2 6. So now the question is, how will 2 oxygen atoms actually share their electron to form your oxygen molecule? So if let's say you're unable to see how they're going to share, right, can do what I have always done, which is to draw in the other oxygen atom. This time around I'll just use a cross. 1, 2, 3, 4, 5, and 6. Okay, so take a look at a lone pair. Okay, I have a lone pair of electron here, lone pair of electron here, lone pair of electron here, lone pair of electron here. Now in order to achieve a stable electronic configuration of a noble gas, right, all the electrons needs to be paired up. Okay, then you will have 8 electrons in the valence electron shell. So what do? I'll just try to pair up the lone pair of electrons. So this electron I can pair up with this electron I can pair up with this. So this is how your oxygen will share the electron. This time round, how many electrons are being shared between each of the oxygen atom? Okay, each oxygen will share 2 of its electron. Okay, total electron shared between each oxygen atom will be 4 electrons. Okay, it will be 4 electrons, and then on top of that, right, I will have 1, 2, 3, 4. Okay, 4 electrons on each of the oxygen atom. Okay, so let's draw our O2 now. Alright, so remember, electron shared between each of the oxygen atom, I'll have 1, 2, 3, 4. So I'll draw a cross, a dot, a cross, and a dot. Okay, I'll alternate between the dot and cross. So this shows that I have 4 electrons that's being shared, okay, between the oxygen atoms. Remember to draw the dot and cross in the overlap area between each of the atom. Okay, now once I'm done with this, right, I'll just go and fill up the rest of the electrons. So remember, on each of the oxygen atom, I will have 4 electrons on the valence shell. So this is my oxygen atom. Remember to write in the key. Alright, so let's take a look and let's count for each of the oxygen atom, right? Have they achieved a stable electronic structure of a noble gas with 8 electrons? Okay, so let's take a look at this oxygen atom. It should have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it has 8 electrons in the outer electron shell. And last but not least, what will be the structural formula? Now this time around, right, since there is a total of 4 electrons shared, this is what we call a double covalent bond. Okay, every 2 electrons is a single covalent bond. So this is a double covalent bond. Electronic structure will look like this. Okay, it's going to be O, 2 lines, O is a double bond. Okay, so this is your oxygen. Now I move on to the next example. Now the next example is your nitrogen. Okay, the next example is a nitrogen gas. N2. Again, diatomic. So you do the same thing, go to a periodic table, right? And look for nitrogen. Okay, you should be able to see that nitrogen has a proton number of 7. Therefore, it has 7 electrons, and electronic configuration, right, will be 2, 5. So each nitrogen atom will look something like this. Okay, take a look at the worksheet. Ask you to draw only the outer electron shell, so I won't draw the first electron shell. So this is just the outer electron shell. Okay, so I'll just draw 5 electrons. 1, 2, 3, 4, and 5. Okay, so again, right, it's N2, right? So if you have no idea how they are going to share the electron, you just draw another nitrogen atom, then you draw in the 5 electron. So how will they pair up? Okay, or how will they share the electrons? So again, right, take a look at the single electrons that are not paired up. I have 1 here, I have 2 here, I can pair them up, and I have 3 here. So actually I'm able to pair them up very nicely. Okay, so a total of 6 electrons that is being shared between each of the nitrogen atom. So this time around I'm going to draw the nitrogen atom again. and I have 6 electrons being shared between the nitrogen atom itself. So I should have 1, 2, 3, 4, 5, 6. What about on each of the nitrogen atom? Are there any electrons left? Yes, okay, I will have 2 over here and 2 over here. So 1, 2, 3, 4. You can draw these 2 electrons anywhere, okay, it doesn't matter. And last but not least, remember to write in the key. Okay, so this is how your nitrogen gas N2 will look like, okay, in terms of the dot and cross diagram. Of course, the structural formula will be N1, 2, 3. Okay, you'll draw 3 lines. So this represents a triple covalent bond. Triple covalent bond. Alright, so we'll take a look at your fluorine gas, oxygen gas, as well as your nitrogen gas.